Okay, so sweet. So as I said last week, kind of this would be a review session, which really I don't have a structure kind of laid out. It's more so if there's any last minute questions, I can work through any problem that you guys have a question on. Just a general topic I can kind of go over if you're having questions or having difficulty with something, and I'll just kind of take these as they come. Before we do that, just to, I think putting this out will help people even if they aren't here today. One thing that I did get done this morning is everything should be graded up to this point. So, you can see all your old online quizzes, all the Learn Smarts, Connects, Excels. But then down here, I kind of have for each one of those categories what your score was once I dropped the lowest, right? So kind of got your lowest Connect dropped, your lowest Excel dropped. So when you look at that, kind of your grades, you should be looking at these categories because these reflect kind of your score in that category with the lowest dropped. And then you would be using those kind of, if you want to play around with that, figure out your grade tool to figure out, if I get a certain score on the exam, what would my kind of, I say potential grade here because it's a potential score in the final exam. But this really tells you what your grade would be, given you enter in all of your information for whatever score you also put in there for the potential, hypothetical final exam score you get. Okay. All right, so are there any particular questions that any of you have? I'll kind of take them as they come in. And you can either say them, kind of unmute, or I'll kind of have this chat open. It just showed up, no questions. Okay, short answer since I make it. Okay, so in terms of kind of the short answer, obviously, I can't tell you exactly what the question is, but what I would say is for the short answer, if I am thinking about what to go over, let me switch over to the dot cam here. So, they make up, like you mentioned, a pretty sizable portion of the exam, but it would probably be something like this. So I can guarantee you, and I think I said this last week, one of them is going to be a short answer, right? So I'm going to give you, a bunch of different variables, some Excel output where you see their different coefficients, you see standard error. I'll probably kind of have this column, which is the test stat. It'll be blank, so you won't be able to see this. And then kind of you'll have your p-value column as well, right? So from some of this Excel output, and I'll show you an example of what it looks like in some of the practice exams, I'll probably have I think it's 5 different, maybe 6 different questions. Some things that would probably be good to go over if it was me. And like I said, I've written the exam, so this is probably good to know. I would know how to interpret slope coefficients. Now, after grading that fifth Excel, I kind of noticed some things where maybe I'm a little worried that people have, not watched anything the last couple weeks, because when I say interpret these slope coefficients, what I don't mean, we'll pull up exam A just to kind of have something to look at. When you see this Excel output, right, what I don't mean by interpret, if I said, interpret the coefficient for education, don't simply tell me 1.233, right? That is the value of the coefficient, but right, we can interpret this. And the way that we interpret this, kind of the general form, and I'll type it just because my writing is terrible, right? So we would say a 1 unit increase in the X variable that you're looking at is correlated with a, for this one we'll say I guess here, I'll keep it general. An increase or decrease in the Y variable. So how do I say this? It's correlated with a increase or decrease of the coefficient value in the Y variable. So, for this one, if we're just kind of thinking, how do we use that general interpretation to match to an example? Well, here's what I saw some people do. It's incorrect. So you wouldn't say a 1 unit increase in education, right? So you don't want to start out saying that, right? Because it's, you know, this is the general interpretation is 1 unit. What is 1 unit of education? Well, if we go up here, we're told education is measured in years of schooling. So you would say, you know, 1 more year of schooling, right? That's the 1 unit increase in education, right? That's the interpretation for the context of this example. Just, I don't know why I put a comma here. It's correlated with a $1.23, you know, I guess 0.33 cents increase in hourly wages, right? So it's the coefficient increase, but you have to put that in the context of the units of our y variable. So here we're told the y variable is wage or dollars per hour. So the increase, the 1.23 increase represents a $1.233 increase in hourly wages, our y variable, right? So that would be kind of how you interpret those slope coefficients. One other thing, that if we have multiple variables in our regression, we said it's still this general form of the interpretation, but we have to add on one little phrase, which is holding all other variables in our regression constant, right? So it's like holding constant experience, age, and the gender of the individual. A 1 more year of schooling is correlated with a $1.23 increase in hourly wages. So we would throw in here kind of like holding all else constant, you can say. You don't have to be as explicit with that holding all else constant. You know, if I had 50 variables, it doesn't make sense for me to, you know, say holding experience, holding age, holding, you know, go through all 50. We can just say holding all else constant there, okay? So know how to make those slope coefficient interpretations. That would be kind of the first thing I would say. The second thing would be kind of know how, and I'd say people did pretty good in this in the Excel. So if we want to interpret that intercept coefficient, right, that'd be another good thing to know how to do. It's always going to be like that first line up here, right? So kind of looking for that constant or that intercept, which is in the first guy right here, right? And the way we always interpret this, we said, was, I'm just going to put it right below here so we can see everything at the same time. So you wouldn't simply say 8.68, right? It's the general form of the, you know, the general interpretation is if all of our x variables are equal to 0, the predicted y value is 8.68 here, right? So actually, sorry, I'm doing this is the intercept coefficient, which means for our example here, for someone with 0 years of education, 0 years of experience, is 0 years old, and female, because the gender variable here, if we go back up, was 1 if they were male, so it has to be a 0, so we'd say if they're female. Then the predicted hourly wage is $8.68. Oh yeah, if we round up 69 cents, right? And, you know, I really was very explicit here. I would count as correct if you said if all the x variables in our regression are equal to 0, our predicted hourly wage is, you know, whatever that value is, in this case, 8.69. Actually, no one's in here. No one's in here right now, so I'm going to take my mask off. Hear me a little bit better. So know how to, you know, make those intersect, and they might be really weird. Like, for instance, it is possible, and this was the case in the Excel example, it is possible that like this maybe is negative, in which you'd be like, how can I make a negative hourly wage? Well, sometimes the intercept just has a weird interpretation, but we would still interpret it that way, right? So sometimes it's a hypothetical starting point because, you know, we never see anybody working 0 years old, and we never, you know, see someone with 0 years of education. So, you know, it is a little bit kind of weird, but that is how we interpret the intercept, okay? Some other things that I would know how to do, and this probably will help you not just on the short answer, but other questions, right? This one should be real easy. It should be the easiest points of the exam if I ask you to calculate a test statistic. So if I leave these blank, all you're doing, and right, we have the formula sheet, and it will kind of remind us that if you want the test statistic for a slope coefficient, you just take that coefficient estimate and divide it by the standard error, right? So if you don't like this form of the equation, if you kind of forget that b hat represents the coefficient value, then you could just say, okay, my test statistic is just going to be coefficient for that variable divided by that standard error, right? So this column divided by this column will give us our test statistic, okay? Some other things I might want to know how to do, right, is rejection decisions. So I don't know why there was a lot of people that kind of seemed confused. I probably should have a counter how many times I've written this down in class, right? It's the same thing for regression output as it is for every other hypothesis test we're doing. So we start out, our null hypothesis is that that slope coefficient is equal to 0, right? Our alternative is that it's not equal to 0. So we can reject the null, right? And if we reject the null, what we're really saying is we reject that there's no relationship. So if we're rejecting that there's no relationship, what we're really saying, another way of saying this, and I want to be able to write something here, so I'm going to move this, right? If we can reject, what we're really saying is that these variables are significant, right? That they have a significant relationship with that y variable. Now, how do we know if we can reject? It's the same decision. If our p-value is less than alpha, we can reject. So I'd have to ask you, what variables can you reject at the 1% significance level, the 5% significance level, or the 10%? Those are kind of our 3 benchmarks, right? Another thing to kind of pay attention to, because I saw some people make some errors on the exam, and I don't have it on this exam, so I'm going to switch to practice exam B real quick, because I believe I did 2 different ones for a reason, right? So if you see the output here, notice these e to the negatives. Remember, these are basically p-values of 0. We're moving that decimal 73 places to the left. This is a p-value of 0, okay? So if you have a p-value of 0, that's going to be less than any alpha we're concerned with. So if the p-value is really low, less than alpha, we reject or say there's a significant relationship, right? So know how to make those rejection decisions. The other thing, and probably a really good way to study this, like it'd probably be even more complicated than what I would give you an example on the exam, but I would go to Canvas, Files, got this homework number 5 here. I put the answer key up, right? So there is a question, I believe it's 2C. Sorry, getting this pulled up here because I think this is worth showing you. And remember, I said, if we want, what are we doing with predictions? Oh, come on. There we go. What are we doing with these predictions, right? And this is kind of that 2C. Notice I'm adding up these values because what this was I went through and I took every coefficient and I multiplied it by that person's hypothetical value for that coefficient. So kind of reviewing 2C would be a really good idea. This is on the fifth Excel. But for the examples that were on the practice exams, so if you go back to this education one, right? When I make a prediction, right, the formula I can kind of think about using is this very last one here, right? So all I'm going to do is take that intercept, right, whatever that estimate was, add to that the coefficient on my first variable times whatever the value for that first variable was. Okay? So maybe here I say, what is the predicted wage for someone with 15 years of education? Oh, not years. Years of education, 4 years of experience, 34 years old, and we'll say kind of female here. Okay? So what I would do is basically use these coefficients, plug them in, right, where they belong, and then take these hypothetical values for x and plug them in. Now I just basically have a linear equation that shouldn't be very difficult to get entered into my calculator. The one thing I see a lot of people do is don't forget the intercept. That always gets added in when you're making a prediction, right? Also, if you have a variable like gender, which is is female, it would be a 0. Well, 0 times the coefficient is 0, you don't have to add that into your calculation, right? However, if this individual was male, right, it would be this times 1. Okay? And pay attention to these indicator variables. So one mistake I saw a lot of people do was, even if the variable was supposed to be 0, they would still add in that coefficient. Well, no, you're not adding in just the coefficient, right? You're adding in that coefficient times the value for the x variable. So if the x variable is 0, 0 times that coefficient, you should be adding in 0 for that particular variable, okay? The other thing I would say, so I guess I didn't write this one down, but kind of making predictions, right, for that y variable. I'll get rid of this box here. And then I would say the kind of sixth thing, potentially I could ask you for linear regressions, maybe on the short answer. If every coefficient is the effect of 1 unit, know how to do things for the effect of kind of more than 1 unit, right? And this is really simple as well, right? If I ask you, what's the effect of 5 more years of experience, right, in that particular example, all I'm going to do is look at the coefficient on experience and multiply it by 5, because the coefficient on experience represents the impact, or how this x variable is correlated with the y variable, the predicted increase in the y variable for 1 unit, right, or 1 year of experience. So if I want the effect of 5 years of experience, I just take that coefficient of 0.417, multiply it by 5. Okay. For the other short answer, actually here. For the other short answer, I would look at, I'm not going to tell you exactly which one it's going to be, but it's going to be one of our hypothesis tests, right? It might be a 2-sample proportion example. It might be 2 sample means with only sample variances. It might be 2 sample means with population variances. So, some of the multiple choice questions will have this hypothesis test questions, but one of those types of examples, will be your short answer. There will be a short answer portion as well. So I can see your work for calculating p-values. I can see your work for calculating test statistics and give a little bit more partial credit there. Okay. So the next question comes like with this alpha over 2 and finding critical values. So I'll break this down for you, okay? When it comes to hypothesis testing, right, we've got 3 different types of tests, right? And I won't write out all the null hypotheses here, but I'll write out the alternatives, okay? So it doesn't matter, I'm going to call this the difference. It could be the difference in sample proportions, difference in sample means with population variances, difference in sample means with sample variances, or it could even be the matched pairs examples. But I'm going to have 3. I'm going to have these 3 different types of hypothesis tests and the alternative hypothesis. So this has a greater than sign. So right-tailed. This has a less than sign, left-tailed, not equal to sign two-tailed. Okay. If these are the signs I see in my alternative hypothesis, this is a one-tailed test. When I'm finding things like critical values for these one-tailed tests, I'm looking up the critical value that gives me alpha in whichever tail, right? So if it's a right-tailed test, we said that alpha would be, we want the critical value that gives us alpha in the right tail, it'll be positive. If we're doing this for a left-tailed test, it's going to be the critical value that gives us alpha in the tail, but negative, right? We don't divide alpha by 2. When it comes to finding the p-value, right? You can kind of think about this as just simply the area kind of in whatever tail we're looking, left or right tail test. And I should say kind of give you a little bit of a diagram here, right? If it was a right tail test, right, once you find that test statistic, right, your p-value is just the area in the right tail. And if it's a left tail test, you'd have your test statistic, it's the area in the left of the tail, okay? Now, if you have a two-tailed test, this is where, well, if I'm looking up critical values, what I need is, I need 2 values that give me, because both sides matter now, or both sides could potentially go against the null, right? If I find a negative or a positive difference, that supports the alternative or goes against the null. So I'm going to have a pair of critical values, and it's going to be alpha total in the tail. So I'll look up that critical value that gives me alpha over 2 in each tail, right? So I'm looking up critical values for these two-tailed tests, which I identify with the alternative hypothesis or the not equal to sign. That's where when I look up these critical values, I divide alpha by 2. Okay? What I'm also going to do there is when I'm looking up p-values, it kind of depends, right? If I see a positive test statistic, I'll find the area in this right tail, and then I multiply that by 2 to get my p-value. It could be for a two-tailed test that I could end up with a negative test statistic, in which case, that's why I always say, look for the area that's more extreme than your test statistic or larger in absolute value. If it's a negative test statistic, going to the left, positive, you're going to the right. And then once again, I'd have to multiply that area by 2 to get my p-value, right? So we only have to do this, right? Divide alpha by 2 or multiply the area to the left or right, area that's more extreme than your test statistic. You have to multiply that by 2 to get your p-value, but only when you have this two-tailed test, which we identify off of that alternative hypothesis having a not equals to sign. Okay. Does that kind of help answer the question there? Oops. Okay. Any other questions that you want to see me go over, or just kind of have in general? You're all just banking on other people having questions. Okay. Let me think if there's something else that will kind of help that we haven't really covered. So one thing I did last class was kind of lay out how you identify when you use which distributions. I could lay that all out again, but one thing that might be easier to think about is we've got, I guess, 3 cases where we use the student t, and then 2 where we use the standard normal. Okay? So I guess one in which, if I see you use the student t, like if this was a short answer question, or it could be a multiple choice, but if I'm giving you sample proportions, and I'm telling you, we're looking for the difference in sample proportions. Anytime I see this proportion, right, difference in proportions, I'm using that z or my standard normal tables, right? So I'll use the standard normal tables when I'm looking up critical values, when I'm looking up my p-value, when I've got proportions. The only other time that we can use that standard normal distribution is if I'm given population variances, okay? So if I see proportions in a problem, or I see that I have a population variance, a known population, critical values, and I'm building confidence intervals from looking at always use that standard normal, right, or that Z table. Every other scenario, you're looking at that student t distribution. So if I've got sample means and sample variances, if I'm looking at that matched pairs or the average difference, or here we don't really go through all the process or the steps, but we could, calculating test statistics for our coefficients. These are all student t distributions. Okay, I guess here student t. My t almost looks like a z there. So now, one thing that's a really good indicator as well is I told you that for these difference in sample means where we only have sample variances, what's something that I have to give you? Well, I don't have to, but I'm going to. I said that we had this really complicated formula, that found our degrees of freedom, which we were calling that delta. I don't even remember what it is. It's something like the sample variance over the sample size squared from both groups divided by the variance over n-1 plus the other one. It's some complicated formula, right? So what I'm going to do in problems like that, and we saw a couple examples like that on these practice exams, if I can find it. Yeah, so up here I only gave you sample variances. Remember, I will give you this assumed true degrees of freedom, right? If if I'm giving you an assumed true degrees of freedom, first of all, if you see the word degrees of freedom, automatically you should be thinking, I'm using that student t distribution. If I'm looking at this table, I forgot to pull it up before we started here, right? The only time I'm looking at degrees of freedom is from that student t distribution, okay? Now, I won't give you the assumed true degrees of freedom when it comes to a matched pairs example where we're looking at the average difference for like the same 42 individuals, because then if I'm looking at this average difference, it simply goes back to, and I'll be reminded kind of by that confidence interval equation here, goes back to simply n minus 1, right? So your sample size minus 1. Okay. Any other questions you maybe thought about while I was kind of laying all that out? Okay. So, one thing I think the material is probably more difficult on this final, but the scope, like how much we really covered is a little bit lower, right? You've really just got hypothesis testing with 2 different populations, right? So we're looking for the difference in means, the difference in proportions. We had this matched pairs hypothesis testing, which kind of looked really similar to when we had one population sample variance examples and the sample mean from the previous exam. And then, of course, kind of our linear regression. Now, I won't make you run linear regression. I'm always going to give you the output on the exam. But all these questions are kind of fair game that we've covered in class. I kind of laid out what you should probably know how to do for that short answer, but also even some of those would apply to some of the multiple choice questions. One other thing I didn't mention, and I don't know, this could be short answer, could be a multiple choice question. When we're thinking about linear regression, one other thing that we want to make sure we know is what that R squared tells us, okay? So our R squared was kind of telling us the proportion of the variation in our Y variable, or our left-hand side variable, explained by all our X variables, right? That was kind of the general form of the interpretation. So if I go back to that 5th Excel, I saw some people having some problems with it. So if we think about, I think this question, right, was asking, looking at this regression where I've got several more X variables or explanatory, right, I'm using these to try to predict Y, than I did in my regression from A, right? I only had 4 of the variables there. So if you notice, with these 4 variables, we're explaining about 37%, right, or a proportion of 0.37 of the variation in birth weights, our Y variable. When I go over here, right, that R squared increases to about 0.45, right? The proportion we're explaining of the variation in our birth weights is about 0.45 or 45%. But that's because, we included the same 4 variables we did before, plus some additional variables, right? And, things like whether or not they were twins or the mother's age probably has a pretty good influence on birth weights. And sure enough, it increased our R squared by quite a bit. Okay? Another thing I could ask is not just what proportion of the variation are we explaining. I might be a little bit tricky, I guess. I don't want to say tricky. I'm not trying to trick you, but I want us to really think about what the R squared is telling us. What percent are we not explaining with these variables? There's still 55% of the variation left unaccounted for, right? Now, we're explaining about 50%. That's not too bad. But if we see, regressions where we've only got like a R squared of 0.05 or 0.1, we can kind of think we have, if we're trying to make predictions in Y, there's 90% of Y that we can't account for. So our predictions probably aren't going to be that great, okay? But kind of knowing that interpretation might be beneficial on the exam as well, okay? Any other questions? They can be real general. Okay. Well, I think I kind of went over a lot of things that weren't mentioned last class. I think these were good questions kind of bringing up here. And I think reviewing, I guess, having it a little bit more laid out in terms of one thing that I think would be really important is when I outlined these 6 different things that would be good to know for that short answer, right? Or for just in general for the linear regression questions, I would make sure I know how to do all these. Like I said, using that 5th Excel might be really good, because we went through, like, if you just looked at the problems on the practice exams, I added in a lot of problems as we were going through them in class, and I did that for a reason, to try to get, those of you kind of putting in the effort and showing up and watching these videos, try to improve your test scores. But here I have them kind of all lined out. You got that Excel homework has a lot of those kind of in it as well, and so you can look at the answer key there and make sure that you really, have a pretty good understanding of how to, if you could go back, how to answer all those Excel questions as well. Any other questions from me? Like I said, I didn't have anything prepared. I was kind of going to go off of the questions you guys brought in. So okay. So I guess some last remarks here. I would say, especially these practice exams are really good for thinking about how, good examples of going over these hypothesis testing and confidence intervals for the difference in proportions, difference in means, and matched pairs. The linear regression stuff, these questions are good, right? There's some that you could definitely see, but also all of this stuff that I added in, like even today, working through all this, I added in some additional questions when we were working through this last week. Even the last Monday when we went over, and then if you're in section 9 last Tuesday, we went through some Excel examples with different data sets and just all the questions that we worked through on those. Maybe going back and watching that video, or at least the portions where we were doing the linear regression examples, that would be really beneficial. Using this 5th Excel assignment for some additional practice with linear regression would be really beneficial as well. I would ahead of time have this final formula sheet open, have your Z and T tables open. You can use Excel if you want, but kind of having those physical tables in front of you would be good as well. And other than that, I think that should be kind of pretty good. One thing I did want to mention, and I hate doing this because I get spammed with emails, and I'm sure you do too, and I put an announcement up already, but today is the last day for any kind of evaluation. So if you do have a little bit of time to get on and do that, I greatly appreciate it. Either way, right? Like even if it's things that I can work on. I mean, this environment is definitely pretty new to me in terms of how to kind of navigate this hybrid. So any comments that you guys have was that you think things I could improve also benefit me, and then it benefits just the College of Business as well to kind of get a higher response rate. So I'll mention that. I'll leave it at that. I won't ever mention it again. Can't promise you won't be spammed with an email from the university today, but I just wanted to throw that out there. So there's no more questions. We'll kind of end it here, but I'll leave this open in case there are. Okay. Well, good luck kind of with your last minute studying. I will be checking my email and trying to respond if you're going through things and have some last minute questions. I'll get you kind of a response over the next couple of days as you're taking the exam. Thanks to you guys as well for a good semester. And good luck in the exam, and have a great summer break.